Okay, today we're going to talk about concavity. Um, not this yet. So a graph is concave up. You can look down here. If it's shaped like a bowl, if it would hold water. Concave down would be like an inverted bowl if it wouldn't hold water. So this graph is concave up from here to this point and concave down, so on. And you can look at the other two examples. To get a better picture. Now, a graph changes concavity at a point of inflection. That's a huge idea in calculus. The point of inflection you can see in all of these three graphs is where it goes from concave up to concave down or vice versa. So that's really hard to find without calculus. So we're going to start very simply, and we're going to see today how you can find these points of inflection. Now, concavity has everything to do with the second derivative. Just like increasing and decreasing was first derivative, concavity is second derivative. So to find points of inflection, in calculus, the second derivative has to equal 0. So all we're going to do today is find possible points of inflection, and that would be where the second derivative equals 0. So I'm going to give you two quick examples of that. They're very simple, especially if you understood what was going on before this. So for this first function, to find the points of inflection of this function, we just had to find the second derivative. So it's a polynomial function, so that's going to be very easy. Or x cubed minus 12x squared is the first derivative. Keep going to get the second derivative, 12x squared minus 24x. Find out where that equals 0. Factor it. Factor out 12x. And then you'll get x equals 0 and x equals 2. And these are possibly points of inflection. So we call those possible points of inflection. Or I call them, because I hate writing so much, PPOI, possible points of inflection. That's it. That's all we're going to go. That's as far as we're going to go today. Tomorrow we'll talk about the actual concavity, how to figure out if it's concave up or concave down. One more quick example. Determine the possible points of inflection of this function. You have to take the second derivative. That's a little bit more entailed. I'm going to go to Wolfram alpha like you can, but I just want to show you something about that. So I typed in what's the second derivative of this function, and it gave me a very complicated function. So you scroll down in Wolfram alpha to find alternate forms, and right here is a much better form, much like easier to use. You can see it's all factored. So I'm going to use this one. And as I'm copying this down, remember, possible points of inflection are where the second derivative equals 0. So all I need to do is find out where this second derivative equals 0 to find the possible points of inflection. The bottom, usually you don't have to worry about the bottom, so we're going to ignore that for now. But if you look at it, the bottom will never equal 0, so it doesn't matter anyhow. This fraction would equal 0 where the top equals 0 as usual. And you can see if it's already factored, you can see the top equals 0 at x equals 1 and x equals -1. And those are your possible points of inflection. And that is it. Thanks for watching.